Very good morning to all. And my name is Ganesh Gauri, Assistant Manager, working as Assistant Manager in Mitsui Chemicals India Private Limited in Solar PV Advisory Division. Okay, just want to share our presence in PV industry and some milestones. So, uh, Mitsui Chemicals has more than 30 years experience in EVA manufacturing, and so moving forward, then we also own some solar and wind hybrid power plants in Japan, and also we collaborated with PA Berlin to get the know-how of establishing the PV lab, and we are um, our affiliated company, Dr. Shioda-san, he is expert in IEC technical committee groups. So that is background of Mitsui Chemicals in the industry. Whereas our milestones are we set up our lab in 2019, and then we got an ABL recognition, which add confidence and trust to the customers, and then BAS recognition, which is mandated by MNRE and BAS. And then we also started some due diligence and diagnostics business, and in future we are also planning to roll out our IEC, other things as well. And overall, we have executed more than 60 projects and 55 sites for customers, and we address many solutions. We address solutions to the many problems. So, and we have diversified team, and diversified team having background from Fraunhofer, Mainz, and so on. Okay, and this is the just background network of labs of Mitsui and PA. So we are currently stationed at Ahmedabad with we have 50,000 square feet lab, which is I think in the world this is the biggest lab for dedicated for photovoltaics. And our Mitsui Chemicals Japan also having lab, and yeah, they are not having, they have partial lab, they are not having complete lab. And they do basically due diligence activities, technical due diligence of power plants, and PA Berlin, of course, they are our partners, and PA China also having lab. So this is just network of labs. And next slide, please. Yeah, coming to the topic of I will start with quality and cost, and then I will also give some glimpses on startup challenges, and in especially solar PV sector, because being in the solar PV industry for more than 7 years, so I am very I have more predominant experience in solar photovoltaics. So I just want to share our experiences in solar photovoltaics. So basically, this is a quality cost balance. So generally, in India, mostly we neglect quality because the trade-off triangle is quality, cost, and time. So we majorly focus on cost and time, but not on quality. So, but the negligence in the quality will definitely impact long-term
Hello,
business.
sir.
Because
You are not audible.
hello, hello, am I audible now? Hello,
Yeah, yeah.
yeah, yeah. So you can I repeat from the beginning, or just this slide I was not audible?
No, no, you don't need to repeat.
Current slide, yeah, current slide I will repeat. So yeah, basically, in Indian perspective, we generally see only two parameters in the this time cost quality pyramid triangle, trade-off triangle. So generally, we in India mostly we neglect quality aspect. So okay, yeah. So the emphasis on the quality. Emphasis on the quality aspects in this webinar. So, what are the costs of poor quality what are the failure cost, and what are the sales reduction, business loss, and so on and so forth. So yeah, with this background, I just want to go. Yeah, this is a pyramid structure. Generally, we see only time and cost, which is visible, and quality, which is like bottom part of the iceberg, so which is not visible, but which greatly impacts the lifespan of PV modules. So yeah, and then so basically, we our motto is to ensure the quality from factory to the field. So right from the beginning of the module production to after reaching the plant, and even after commissioning, and yeah, even after operational maintenance also. So how the module behaving, how it should be generating quality power performance should not degrade much faster. So these are the major concerns which are currently facing by the PE market. And yeah, so yeah, basically these are some steps like structured approach to strengthen the quality. Like there are several standards which are set already. BAS has mandated some standards for IS 1426 and 61730. Basically, that is for design and safety qualification. And then and for designing of power plant itself, there are some more standards like 62548 and 62738. And then and operation and maintenance commissioning part, there are 62446 standards, and performance indicators are 61724. So basically, the kind of challenges every startup company faces is like, first of all, the design thinking itself, because the idea, starting from the idea, so the idea to implementation, the major gap is yeah. So one is like we have everyone having ideas, but yeah, ultimately from developing idea and making to materialization, it will take a lot of efforts, and there are a lot of uncertainties related in this, like technical uncertainty, process related uncertainties, material related uncertainties, and market uncertainties, and financial uncertainties. So these are the some of the major hurdles to any startup. And of course, solar lab of Mitsui India is also like a startup, and we have also seen a lot of ups and downs during establishment and accreditations, and even COVID situation also. So yeah, so basically one should know each and every step, and the uncertainties related to each and every stage, because that will eradicate major hurdles, or at least if we get to know, if we measure the things, then we can able to optimize, or we can able to reduce the uh, risk. So that is the object of this. Yeah, so okay, sorry. So basically I just want to show some more slides. Okay, so okay, so why standards are important, I will skip some slides because due to time limitation. So in India, so BAS is mandatory to gain market access, and in China CQC, and in Europe TUV, CB, and VD, and UK MCS. So these are the various standards uh, which need to be performed before entering into the market. And also the market is dynamically changing, as I mentioned. So market the technology is evaluating like rapid manner, and so the upgradations are pretty fast, and the standards are actually lagging behind, because the standards basically they draw a reference line where from which the basically uh, everyone can give the harmonized results. So standards set that uh, stage to everyone, a level playing field to everyone to deliver the harmonized results. So the market is really dynamic, and there are uncertainties. Okay, uh, so especially this presentation, we just want to touch upon few stakeholders like manufacturers, bankers, investors, and yeah, and developer, insurance agencies, and all. So yeah, basically we will show you some failures which we have seen, because the PV market in India is still name. So there are many. we are yet to be matured. Like yeah, European and other continents, they are already the countries, they are well matured. They are already seen the failures, and they were evolving into good perform, yeah, good quality materials. So basically, this slide shows the various standards related to from component level to module level and system level. And yeah, we basically for each component, the testing is a must, and every component which is entering into India, so there should testing is mandatory, made by MNRE and BAS jointly. So yeah, these are the some standard numbers like glass, encapsulant, solar cells, and backsheet, connectors, cables, and so on and so forth. And module level, once the design is done, then design and safety qualification and reliability of the module. So and energy rating, PAD and LETAD. So new due to the new technologies, new failures also developing in the market. And in the system level, also there are a lot of standards like for designing of the, and so 6258 off grid and on grid 62738, and for commissioning 62446. And yeah, so this is the screenshot. Yeah, and after post commissioning, the performance indicators is 61724. So what actually the standards and why they are necessary, and all, this slide will depicts, it will try to, yeah, this slide will explain why the standards are necessary, and why the MNRE and other regulatory bodies are made in mandate to undergo this testing. So basically, this is an example of a table, and where the components are like drawers and all desk. So if we purchase even individually components separately, and we combine together, so the output will be like this. So the table will be ready, but there will be no standard or no uniformity and all. So whereas the right side, the example is we have table, we have drawers, and but here, so the quality, the testing, and the metrology also follow. So basically, it's like measuring each and every dimension, and then harmonizing, and then assembling the desk with the drawer. So that will provide the uniform and harmonized results. So that's why manufacturers, new manufacturers or new entrants in the market, they have to first of all should know whether the standards have been met or not for BP models and all, from starting from the module to the power plant level. So like I have shown in my previous slide. So this is one example, and then uh, so basically labs and all labs are just one step higher than manufacturers. So basically we do calibrations, we maintain reference standards based, and we give the reference standards. We transfer the quality to the manufacturer so that they can also have the traceability of unbroken chain up to the international standards. So this is one such example, like how pyramids have been built, and with that much consistency, and yeah, with accuracy and all. So basically, they follow the. They also used to calibrate the wooden cubes in full moon days. So that, yeah, this kind, and they used to calibrate it every 15 days. So that reduces the error, and eventually the pyramids now, which is the one of the seventh wonders in the world. So basically, that they have taken a lot of time, and they really quantified the errors, and they eliminated the errors, and yeah, these are the approaches, and these are the live examples which have been said by our ancient people. Yeah. So now I will move ahead with some of the failures which we have observed in our testing. And yeah, basically we'll show you mostly on PV models testing. uh, so base, uh, so normal standard tests will not fulfill the reliability, means they can't reproduce the reliability issues. So basically the reliability testing, yeah, so extended IEC and all, they from which we can get the life cycle of the model or lifetime lifespan of the model. Basically, how much there are like performance warranties are there, there are product warranties also there. So without product, the performance will not exist. So the product should first of all withstand the accelerating tests and stress conditions. So basically, some of the project extend IEC project, we have found that backsheet was started cracking, and you can see the backsheet also become yellow. Maybe screen to screen it may vary, but yeah, screen yellowing and cracking was we have seen. So this is one defect. And another extended IEC project, we have seen that interconnects have been broken. The initial picture in the on the left and the right side is the post TC600. You can see the interconnects are completely isolated, and the power loss happened. So these are the reliability indicators. And next thing is the nameplate actually. So basically, the uh, uncertainties starting from material selection process and equipment measurements and even testing lab. So whatever reference material standards they set. So these all together they contribute to the uncertainties. And the nameplates, basically, yeah, now the nameplates are bit more stringent. Like now, mostly we will see positive tolerance only, no zero negative tolerance and positive tolerance side. So basically, the nameplate tolerance we have tested more than 60 projects in the last year. So this is just a trend of how the tolerances have been changed. See the so most of the when we keep the 3% tolerance, most of the manufacturers are outside this band, so which is not a good sign for the PV market. Whereas in 5% tolerance, yeah, most of them are sitting inside this span. So basically, this indicates that the tolerance still the nameplate tolerances will not match actually in actual scenario. So that is the outcome of this. So everyone has to verify. The stakeholders or end user has to verify the output before going to yeah purchase and all. And then this is one wrong selection of material itself. So one customer has by mistaking or somehow they have used 1,000 volts backsheet whereas they asked us to test for 1,500 volts. So you can see these are basically EL images. It's like X-ray of modules. So we can see cracks or degradations from the X-ray. So you can see the module after several rounds. So it was completely dead. So these are some risks actually concerning to the material selection and all. So that's the objective of this. And then we have compiled together the history of the and failure trees. Failures happen in the PU models and components basically. So PU model consists of lot of components as I have shown in my previous slides. So this is the failure tree. So we certainly everyone has to maintain the failure tree. So failure is not like dead end. So it is a just opportunity for improvement. So it's like betterment to the yeah, it's a betterment to the yeah product. So basically we should consider as a positive manner failures means. So yeah, so and yeah, to avoid that, MNRE has issued quality control order uh, to limit the poor quality imports from Chinese manufacturers and all. And yeah, this is some statistics I just want to show. Yeah, like uncertainties which contributes to the measurements as I mentioned in the last slide. So 3%, 5%. So the basically the statistical distribution when we measure like more than thousands of models. So how the distribution represents. So this is the slides. And yeah, I just want to skip some slides which are not relevant. I don't want to go in detail also. And yeah, this is one another example of hotspot for certification. And when we taken randomly from the lot, the always of course everyone sends the good samples for testing, whereas in production the quality deteriorates or maybe the BOM changes, and also quality is, will not maintain as shown or as committed in the documents or on the data sheets. And further O&M related things, uh, so basically we so nowadays the O&M things also, operation and maintenance, really taken a lot of boom, and especially robotic cleanings. So robotic cleanings, and due to shortage of manpower in the COVID scenario, so the robotic cleaning has took really big way. So it actually improves the PRs and capacity utilization factors and all. So, and it doesn't require much effort. So robo automatically in the evening, so it can they can clean automatically, and they can come to docking station. And there are several robots already, and yeah, we also tested I think 4 5 types of robots so far. So yeah, and this is the impact of dust. So soil is the first major performance killer in PV power plants, as far as PV power plants are concerned. So the depreciation of yeah, power plant will also majorly impacts due to soiling, and the loss also, we have quantified the loss per kilowatt per and to megawatt, and even more than several megawatt, tens of megawatts. So the more the larger the size of the power plant, and the more the soil will, more impact will be there. So nowadays most of the players are adopting these robotic cleaning simulation systems. So for 10 megawatt, the loss is almost like 1 million INR. So that is a huge amount. So yeah, that is one thing. And yeah, so related to lab errors, so far we have discussed about some material related errors, and then power plant O&M related errors. So lab errors also, how to like being a new startup lab, so we have first of all validated our measurements. We have undergone PT with Series Singapore, and we have verified where we are standing actually. And you see the all measurements are actually very precise, and they are all concentric and in the middle of this dartboard kind of thing. So yeah, generally interlab comparisons, PT is more sophisticated than interlab comparison, so which gives both jet score and en score, which are important, uh, which are like a reliability indicators and performance indicators for a lab. And yeah, while selecting this equipment also, there should be some because in manufacturing lines, so equipment production line measurements are very much important. So basically the sun simulators which are used in production lines, they basically impact the error, the uncertainties, of course. So generally now the AAA plus is a more boom. So most of the technologies, and also monoperk and all, some technologies like HJT, monoperk, and Topcon, and so on and so forth. So they require long pulse, as well as they require more sophisticated sun simulators like AAA plus and all. So I don't want to go in detail. So basically this is the non-uniformity maps for full cell, half cut cell, and we generally measure at every inch of the sun simulator, and so we know the error contributing in the measurements. So this is such slide like major contributors in power measurements, because the power is the driving factor in the PV market. So one is the spectral mismatch correction, because that is a majorly neglected thing, and non-uniformities, and calibration and repeatability of the equipment itself. So next is the one such issue is the one such, one such issue is the uh, cell to module loss itself in a manufacturer. Manufacturers generally, yeah, while new manufacturers or startup manufacturers generally, so when purchasing a cell and when building the model, so they think that cell power and model power will almost match, or efficiency will match. But in general, there are a lot of loss components. These are called cell to model loss components. So I don't want to go in detail because it will take some time. So there are geometric losses, optical losses, and electrical losses. So yeah, so basically with some using some this is one such case of increasing the thickness of the interconnect, so how the efficiency can be increased. So this is one example of how CTM loss can be improved. And basically this is the entire for any organization, equipment and components, materials, personnel, and process. These are the four M's which are predominantly present in any organization. So being a startup or new into this market, so one should aware of the equipment, whether the uh, technical specs they have given, whether matching with the actual mission delivered, which is being supplied by the vendors. And the components also, one should ask the certificates and reports, test reports from the suppliers, component suppliers or material suppliers. And personal, of course, the skill level and the awareness and how much they proficiency is there in delivering the results or in delivering the process. And then last is the process related itself. So the process itself, as I have shown, CTM is the one process related error. So yeah, so actually we offer the entire uh, uh, end-to-end solution which enhances the production uh, quality in manufacturers as well as things. So I just want to quickly show you these slides why so the failure bathtub rates, bathtub curves, and so how can we can be basically after power plant installation. So basically while doing regular maintenance, O&M and all, by keeping up yeah, the power plant in good condition, so we can reduce that by maintaining at regular intervals. And the risks in every step is there, starting from the designing to manufacturing and installation and commissioning. So everywhere there are risks. So that's why IEC has made some standards like IEC standards and even IEC standards for starting from the designing of the module to designing of power plant, design and even post commissioning, and after and even O&M things. So at every juncture there are some standards which are like gateways to go to the next step. If any one of these are bypassed, then the quality chain, the quality cannot be guaranteed. And the standards, general standards which are being mandated by BS or IEC, they are not enough, because the reliability, the product life is the more important than just design. So it's something like a small hammer, the standards and all. So they are not much impacting. So we need a big hammer like Thor hammer, so which definitely quantifies and reduces the risk and uncertainty of it. So that's all. I think I will conclude this. So yeah, any questions I can appreciate. Yeah, thank you so much. I'm now stopping my presentation.
Uh, yeah, thank you, sir, for sharing your views